Hello everybody and welcome to a new episode of learning about the SEER database. Today we're going to learn how to calculate the crude incidence rate, the age-specific incidence rates, and the age-adjusted incidence rates of any cancer using the SEER stat software. I was hoping today to give you a more practical session using the SEER stat software, but due to some technical problem that I've got with my software, I've decided to give you like an introduction to the topic because it's very important and many SEER-based research papers have been done using that metric of cancer. So it's look at this video as an introduction to how to calculate specifically the age-adjusted rates, because the crude rates and the age-specific rates are just for your knowledge. But if you're going to compare the cancer incidence rates between two populations or within one population across time, the age-adjusted rates will be the most important. The first thing that we need to do is to go to this web page. I've highlighted the URL for your kind care, and I will put it in the description of the video below. And this describes a step-by-step approach to calculating the age-adjusted rates. And along the way, we are going to know as well how to get the crude rates and the age-specific rates. So basically, when you go to this website, the first step that we have to do is we can get the age groups, the specific age groups of any cancer using any registry on the SEER database. And for this table that is shown here, there are about 18 age groups here in this table, starting from 0 years, which means below 1 year of age, and going on till over 85 years of age. And for every age group there is a count, which is the number of new cases that are diagnosed for such a cancer. Using this count within in comparison to a certain population, which is called the people at risk of developing this cancer, we can get the crude incidence rate like we will show you next. So this is like the first step, and when you click next, they will show you the population, and they will show you the crude rates, which actually is this count divided by this population times 100,000 patients. And they are showing it here in this formula. So the crude rate is the count over the population multiplied by 100,000 patients. And that crude rate will be like 20.7 cases per 100,000 patients. You can scroll down and you can check the calculations yourself. So this is how we get the crude rate. And actually the crude rate, if it's given in relation to specific age groups, we call it an age-specific crude incidence rate of the cancer. For the 1 to 4 years of age, we have got a count of 78 new cases, and if we divided it by the number of the population, which is 553,198 patients, it will give you like a number of zeros before that 15, so that when we multiply it by 100,000 patients, we get the 15.7 cases per 100,000 patients at risk. And that is the crude rate, that is the crude incidence rate of that cancer given within that registry and according to this population in which the cases were detected, and that is called the crude rate. And within a specific age group, I repeat, this will be an age-specific crude rate. Here they are giving you the SEER registry in which they have extracted this data. Now we'll click next. So this is how they calculated the age-adjusted incident rates. So within each age group, they have put in the count column and the population column, and that's how we got the crude rates. And this is for your knowledge, this is not for your comparison. Like up to the crude rate and up to the age-specific crude rate, it's just for knowledge. But starting from here, starting from those three columns on the right, we are calculating an incident rate that we can use for comparison, because it was proven that the crude incident rate of a cancer is dependent on age, and by adjusting the crude rate to a new age distribution of a standard population, we can get a new crude rate in which we can compare to other populations as well. I don't know if you understand this from the first time, but it is well known that crude rates depend upon age, and the crude rate depends upon the composition of the population. Like if a cancer is more prevalent within a certain age group, like if it's more prevalent in older people, and it happens that a certain community is composed of like 80% old people and 20% younger people, so this will give me an overrated crude incident rate. But if we compare this to a standard population in which another distribution of the age groups is presented, then I can relate this crude rate to this standard population to get a standardized age-related incident rate, and that will be more accurate and more suitable for comparison. So if we see this example before us within the same table, we can see that within the 1 to 4 years of age, the crude rate is 15.7 cases per 100,000 patients, whereas if we related this to a US standard population with a new weight for this age group, like this is the new weight for this age group, we get a new incident rate, an age-adjusted incident rate of 0.87 case per 100,000 patients. How did we get this number? It's simple. First of all, we get the different counts of the different age groups within the standard population, and then we divide it by the total of this population. Like if we divided the 15,191,619 patients of the 1 to 4 years of age group divided by the total, then we get this distribution. And all we have to do is, after getting this new age distribution or the new age weighted distribution, we then multiply this by the crude rate to get the new age-adjusted incident rate, the age-adjusted incidence rate. And you can repeat this in all the other age groups. So you can see now how different the age-adjusted incidence rate differ from the crude incident rate. You can repeat that for all other age groups, and then you can get the age-adjusted incidence rate, which you can use for comparison. Like I said, this is an eye-opener. This is an introduction, and I'm sorry that I did not make any practical applications on it using the SEER stat software, which I will do once my technical problem is over. So I hope I have gained your attention, I've raised your attention on this new topic, and in the next episode we'll have more practical examples on how to make these using the SEER stat software. Thank you very much.